I'm not saying we know how to cure anything. All this is about is research that is on PubMed. You can go find it, and if you want to know more about it, send me an email. I'll send you the link. Because this is where this came from. It came from some research done by a PhD in I think it was Memphis State or something. And in fact, on the bottom you can see the name, and it's I think her name is Marcy Purnell. She was originally a nurse practitioner and was using a magnetic affecting device or piece of equipment and getting remarkable results. She takes this information and she says, well, I want to do some research on this. Well, you can't do it, you're just a nurse. So she gets her PhD, and part of the PhD then she wants to do the dissertation on this, not the math, on the magnetism in the body and the cells. And there's been a lot of research that this covers anyway, but then basically the guy in charge of the money and the research says, well, prove it to me. And so she did in a matter of weeks, and he said, well, go for it. And some fascinating research, but this is like a highlight. Now, Dr. Tennant, Dr. Katsanis, of course, who we deal with a lot, many others, we've known for a long time that voltage is really important in the body, right? Voltage is critical. Every single cell has voltage in it. It has current in it. Every single cell produces magnetism, because if you're producing electricity, you're producing magnetism at some level. It could be pico or nano, which is billions and trillions, but it's not much. But when you have 70 trillion of these added up, it's a lot. We also know from vast amount of research, and they can measure this, they've been measuring this for some time, that there's a voltage called membrane voltage, and they call it, what do they call it?
Biopotential.
Membrane potential. Is that right?
Biopotential.
Biopotential? I think that's close. It's a voltage difference between the at-rest voltage inside of a cell versus the voltage outside the cell wall. So it's a transmembrane potential that tells us the condition of the cell more than anything else. And that cell will operate at a particular level to do its particular function. It could be a liver, a gallbladder, it could be a brain, a neuron, it could be a muscle cell. It operates at a particular voltage level. And there needs to be a difference between the outside and the inside. And that difference is absolutely critical. And what this chart shows you is something that is quite revealing. In the research that was compiled, you'll notice that they contrasted, or she contrasted, tumor cells and non-tumor cells against where the transmembrane voltages were. And it's called VM, voltage across the membrane, versus inside versus outside. Inside a cell is going to be more negative from an electrical voltage standpoint than the outside, where the fluid is. It's going to be a lot more negative. But when you have a condition where the inside and the outside don't have a lot of difference, certain things are more likely to take place, as evidenced from here. So if you look on the one side, on the left-hand side, you have a ovarian tumor, you have a leukemic myoblast, human, my glasses, I got the wrong ones, hepatoma. So you have all these cancers over here. And you notice they all appear and live where the contrasting voltage between the inside and the outside is about 50, in other words, a negative 50 millivolts, or what would be less, which would be more positive. All right? Now, notice another thing. On the right-hand side, it shows you non-tumor cells And for those of you who've done a lot of cancer work, you know that they've always talked about fibroblasts and different things that are just like cancer. They grow just like cancer, but they're not. And look at the first thing on here. The lowest energy thing there is up here on this chart, anyway, is the fertilized egg. The sperm gets in the egg, and now it's fertilized. It's practically at zero. What happens is the egg has to grow. It has to proliferate. A little further down, you'll see a 4-cell embryo, about 25. So the difference is expanding. Then you'll see 16 cells as it begins to expand even more and grow. And then you have the liver here and some other things. What this shows is that for cells to replicate, they tend to have a lower, when the point of replication occurs, they tend to have a lower differential from the inside to the outside. That's what her compilation of research and her own research showed. Because when you get down here, at the higher level voltages that you want, which is typically 70, 80, 90 millivolts difference between the inside and the outside, there's no growth. There's no replication, there's no proliferation, there's no differentiation anymore. Differentiation means like when you have a stem cell come out, it doesn't, we don't know what it's going to do yet. It goes somewhere, it ends up in the heart, and it becomes a heart cell. It differentiates from a nondescript stem cell into a now functioning heart cell. That's differentiation, right? Fair enough? When a normal cell proliferates and replicates, it has to, it's what they call an action potential. I don't want to get into this too deep, but it has to have an event occur electrically inside the cell that allows it to then multiply. And you'll notice that all the multiplying is at the low end of the energy pattern, right? So that's why when we have an adult muscle, we have to really work out at working out to make that muscle replicate and get more muscle cells. It takes a lot of energy to make a muscle cell. In fact, the skeletal muscle is like the highest one on this chart. It's over 90. You want to have a huge, so just to live, that muscle cell needs a lot of energy. What is way cool about this is that when we're using technology, ozone, magnetism, which we're going to demonstrate in a second, and microcurrent, we already know from other research and this research that it brings the cellular energy differential up. We're elevating ATP in the mitochondria. We're creating an environment where the cells can function normally. What all this, in this research that she did and other research, this is between 2013 and 2016, by the way, basically. So it's fairly new by research standards. It shows that the energy, when it reaches a certain point, it's not going to go hog wild because the energy is there for the gene expression to be correct. Gene expression is what happens when you have cancer. It goes hog wild. You still have expression, but you're turning off certain regulatory genes, and cells can then replicate at will, depending upon what that cell is normally going to do. There's a lot more to this. But what they found out, and the indications from the research is that when you elevate that energy back to a more normal level, for that particular, whether you liver, muscle, whatever, that you have everything working better. The regulatory genes are functioning. They actually are telling us in this research that they believe that the tumor, you can stop tumor growth just by getting the energy up here. And isn't that what we do every day? This is like mind-bending stuff. I mean, yeah, we do it, but there's actually research that is not just on a particular frequency that tells us, oh yeah, 1 hertz does this. That's all well and good. But this is big picture stuff. So we wonder why we feel better when we use this device, or as we'll see, when we use this, or when we do ozone, we wonder why we feel better. We shouldn't. because we're getting the energy back where it belongs so that all the functions can occur right. The various ion channels begin to operate right. They did one of the particular parts of the study, which it may be a minor part, but it showed that the chloride ion channel is very permeable and it works really well, and that's amazingly instructive to know how to get that energy back to the 90 without getting too deep into it. So I wanted to at least have that. If you want more information, email me something. I will send you the links. I'll get you to the research itself. If you're interested in that, I didn't want to bore those who are not interested in it, but I did want to show you that both healthy cells and unhealthy cells need to replicate rapidly like an egg does, but once they're done, they don't. So if you can create a don't environment, you stop the replication that you don't want. And now it's back to normal. And also in that same study, they showed where they elevate the energy. Instead of a cancer cell unregulated producing 2 cancer cells when it divides, it now produces 1 healthy cell when it has the energy to do so, when the genes are right and the energy is there for the gene expression.